Hello, everyone. Welcome to our webinar. Today, we are going to discuss how to conduct and interpret t-tests. My name is Justin D'Souza. I'm a quantitative specialist at Statistics Solutions. So I'll go through the entire presentation first, and then we can do a question and answer session at the end. So if you have any questions, you can type them into the chat box. You don't have to wait until the end. If you think of a question, you can type it in. And then I will review those at the end of the webinar today. We'll send everyone a copy of the webinar as well as the PowerPoint. And just let us know if you have any questions. I am recovering from a cold, so I might lose my voice a little bit here and there. So please forgive me for that. But let's dive in. All right. So first, I'll give a brief overview of the services that we provide at our company. Then we'll look at how to set up a t-test, what is a t-test, when is the best time to run a t-test. There are three main types of t-tests. There's an independent sample t-test, we have a paired sample t-test, and there's a one sample t-test. We'll look at an example for each of these in the SPSS software, and we'll conclude with a summary and a question and answer session. All right, so on this slide, you can see the different parts of the dissertation journey that we assist with. Our company helps with virtually every part of the dissertation journey. So we have methodologists, both quantitative and qualitative, that work here, as well as literature review specialists. So if you're doing a quantitative study and you need more help with the methods, then we can help you with that specific portion. Likewise with qualitative, if you need help pinpointing your research design and justifying it, figuring out your research questions and your hypotheses, what is the minimum sample size you need to target, finding appropriate instrumentation to address your questions, and identifying the best analyses to address your hypotheses. So we can help with virtually every part of the dissertation. We also have data entry templates we can provide to you. If you're not sure how to set up your data, we can host a survey for you on our SurveyMonkey account. And if you send us your methodology and the data, in addition to the scoring instructions for your surveys, we can run the results for you in SPSS or our company software, Intellectus. And we can provide an API write-up for you. We also help with the discussion, PowerPoints for proposal and final defenses, and we can help condense your dissertation into a journal submission. So if you have any questions, you can give us a call at 727-442-4290. And my colleague Sierra is putting some hyperlinks in the chat box for scheduling free consultations. And you can check out our free dissertation resources on the website as well. All right, first we're looking at the independent sample t-test. If you've joined us before, I've done webinars recently on tests of differences and ANOVAs. T-tests are much simpler than ANOVAs. The key thing with t-tests is usually it's a comparison of two groups or two different points in time, whereas an ANOVA is looking at comparisons between three or more groups or three or more points in time. So for a t-test, you need to have a continuous dependent variable. That is a variable that is numeric, that falls on an interval or a ratio. And you're looking at two distinct independent groups that you want to compare. What do you need to run a t-test or an independent t-test? You need to have an independent variable that is dichotomous or binary, two distinct groups, whereas there can be no overlap where one participant falls into multiple groups. There has to be independence between your two groups. So examples of this are gender, or groups in an experimental study, treatment versus control, or maybe you're comparing two classrooms. You need to have a continuous dependent variable. And then prior to any statistical analyses, you'll want to check for the assumptions of that test. So many tests will have a prerequisite that you need to verify before running the actual t-test. So you can check that out here. This is the statistics layer website, which will go through every statistical analysis and explain how to run it in SPSS. And it also identifies the assumptions that you should check. So for a t-test, a lot of these are definition based. They aren't things you have to mathematically or statistically verify. So your dependent variable needs to be continuous, meaning it's measured on an interval or ratio level. The independent variable needs to have two distinct groups. So we've talked about those two. You need to have independence of observations, meaning no overlap between one group and the second group. And then these are more the assumptions you can check in SPSS, running different analyses. So the first one is absence of outliers. You don't necessarily want to have outliers in your data set. That would be a big question for your committee, because some committees will want you to remove outliers. Other committees, especially if you're dealing with test scores for students or GPA, that sort of thing, it's often frowned upon to remove cases, even if they're outliers. So it's a very specific topic regarding outliers, but I'll show you how to check for those in SPSS. The next assumption is normality. So if you've joined us recently, I've gone through a couple webinars showing you how to check for normality. I'll do a brief recap of that today. There's many ways to check for normality. And then the final assumption is homogeneity of variance. So this is making sure that your data are spread out evenly between the two groups that you're comparing. And often a Levine's test is used to check for this. So let's look at an example here. Right here, I have some student data with 150 students. We have their gender identified, and we have math scores, science scores, and a reading score that was collected in the fall, and then it was collected again in the spring. So things to keep in mind, if you're just gathering your data and you have it uploaded, first add an identifier column, just number everybody from 1 to however many participants you have. If you have demographics like gender, age, ethnicity, if you're planning to use those as variables in your research questions, you'll most likely need to convert it to a numeric format. So we have gender here, written out in the string format. That means words or letters, but then I converted it to numbers. So 1 is male and 2 is female. And then you can identify that here in variable view. And then we have all the test scores here. Okay, so hypothetically, let's say we want to assess for differences in these scores between males and females. We could run an independent t-test here because each of these scores are continuous, and we have 2 distinct categories for gender. So to run, the first thing would be checking assumptions, normality, homogeneity of variance, potentially removing outliers. So you can go to analyze and then descriptive statistics. And this is one of the best menus or the best analyses you can run. You click explore here. It brings up this menu, and we can shift all of our continuous dependent variables to this box. And then we'll click plots. And you can select this option right here, normality plots with tests. And then you can also check mark histogram. And that's it. So we'll click OK. All right, so this is going to give a lot of information. We have math, science, reading pre and post. You can see the mean, standard deviation, the minimum score, the maximum score. Skewness and kurtosis might be something your committee wants you to report on. And then we have the tests of normality here. So this is one way to check for normality, is using a Kolmogorov-Smirnov test or a Shapiro-Wilk test. And for this, a non-significant result is an ideal finding. So non-significance for these findings would mean that your data resembles a bell-shaped curve. Good thing. So if the p-value is above 0.05, then that means the assumption is supported. So we do have that for both tests. P-values are non-significant, meaning that normality was supported using these tests. That's one method to use. Probably the most frequent method I see is a Shapiro-Wilk test. But you can also interpret normality visually by looking at a histogram. So that is also presented here. And we can see for math that quite closely follows a bell-shaped distribution. For science, you can draw a bell-shaped curve around this. Same with reading, it peaks in the middle. And then for reading, this is reading post. This also follows a bell-shaped distribution. So it's going to be a committee preference thing, for what method to use to check for normality. I prefer to use Shapiro-Wilk because it's more of an objective finding. Excuse me. Whereas histograms are more subjective. Everybody's going to interpret a histogram differently. Okay. So the other way to check is looking at QQ plots or normal PP plots. And as you can see, these are all presented in that one analysis under Explore here. So we have the check for normality with histograms. We have normal QQ plots. Ideally, you would want your data to follow this diagonal trend line. It does. So your data would be the blue circles. The black line represents perfect normality. We do meet that assumption multiple ways. All right. And then outliers is another assumption, as we talked about on statistics layered. There should be no significant outliers, but again, check with your committee. They might not want you to remove outliers. And you can use these box plots right here. And outliers will be identified in SPSS if they have a star next to them. So this case right here, this person scored quite high on math. It was like a 106 or so, but it's not starred. It'll be like an asterisk symbol if it's an outlier. In this case, it's just a circle. So we don't have any outliers for math. Don't have any for science. None for reading. None for reading post. So in this case, I would not remove any cases. And to run the t-test now, we'll go to compare means and then independent sample t-test. Then we can put all 4 of our variables. The good thing about this is you can run multiple t-tests at once in SPSS. You don't have to do it one variable at a time. We can throw them all in at once. And you need to put gender in here. All right, and this is what the t-test reports. So you can see math, science, and reading. What are the scores for males and what are the scores for females? What was the sample size in each group? What is the mean for each group and the standard deviation? So the first thing we need to do before we look at the t-test finding is testing homogeneity of variance. So this is making sure that the standard deviations essentially between your 2 groups are similar. Okay, so it's looking at this column and it's asking, is the spread, standard deviation is a representation of spread. So it's making sure that the spread is approximately similar between males and females for each variable. So you'll see that assumption is checked right here. Levine's test for equality of variance. And similar to the normality check that we looked at before, but the Shapiro-Wilk tests, coming back up here, this test here where non-significance is a good thing. It's actually an ideal finding. You want p-values greater than 0.05 for a normality check and for homogeneity of variance. So we do have p-values greater than 0.05 here, meaning that equal variances can be assumed. So that means when we interpret our t-tests, we just go across the top row here, equal variances assumed, equal variances assumed. Hypothetically, if we did have a significant finding here for Levine's test, we would then interpret the second row, equal variances not assumed. All right, so because equal variances were assumed, we met the assumption. We go across this row, and you would report this t-test value, this degrees of freedom value, and this p-value. So the p-values are ultimately telling us, do we have a significant difference in the score between males and females? And if the p-value is below 0.05, then we do have a significant difference. So we can see for math, the p-value right here is 0.007, which is below 0.05. Therefore, we have evidence that there is a significant difference in math between males and females. So you can kind of double check that up here, and this will help you write your narrative. So there was a significant difference. What was the difference? The difference was that males scored significantly lower than females, about 3 points lower. Now for science, reading pre and reading post, you can see the p-values are all not significant. They're all greater than 0.05. So we don't have evidence of significant differences for science reading pre, reading post by gender. All right, so that is a independent t-test. The next test is a paired t-test. So this is looking at differences in a matched variable. Usually this is a pre-test and a post-test type of comparison. So you need to have the same participants who did the pre come back for the post. It can't be two different samples. It has to be one sample. So how do you set this up? Again, you need to have one matched dependent variable that is measured twice, not more than twice. If it's more than twice, then you can do ANOVAs. But in this case, we only have 2 points in time. So you do a paired t-test. Then you can check for the assumptions here. They're fairly similar, that there are fewer assumptions for a dependent t-test. And again, they're very definition-based. So the first one is you need to have a continuous variable. Then you need to have two related pairs or groups, like a pre-test or a post-test. There should be no significant outliers. And then normality also needs to be supported. All right, so for a paired t-test, we have a reading pre, so reading in the fall and reading in the spring. We can go to analyze, compare means, and then paired sample t-test. And then just select your pre and post, move it to the right box here, and click OK. And the interpretation is very similar as the independent t-test. So first off, we see what was reading at pre-test of 84.99. That increased up to 85.90, so about a 1 point increase. And then we look at this table here. We can see the mean difference. So specifically, it was about a 0.9 difference, 0.9 unit difference. This is the t-test value you would report. This is the degree of freedom you would report. And then this is the p-value. P-value, again, was significant here. It was below 0.05. So we do have evidence of a significant change in reading scores between reading pre and reading post. All right. So we talked about the normality assumption already. We'll go too heavy into that. But what you can keep in mind is if you do not meet normality, you can shift to non-parametric techniques instead. So if normality is not supported, you can run a non-parametric backup. Okay, so remember this was our t-test that we ran, the independent t-test all the scores by gender, but hypothetically say that normality was not supported on these variables, then you can do what's called a Mann-Whitney U-test. It's a non-parametric backup to a t-test. So you go to Analyze, non-parametric tests, legacy dialogues, and then 2 independent samples. So it's quite a lot of menus you have to jump through. But here, 2 independent samples. And then you set it up the exact same way. This. 2. And just make sure that Mann-Whitney U is checkmarked here. And this could be a backup that you present. Okay, so we did see similar findings. Math is the only one that showed up significant. Science, reading, pre and post were close to significance. But I would not even go to this step because we did meet the normality assumption, so you don't need to use non-parametrics necessarily. All right, and then, likewise, we did a paired t-test. We did a paired t-test for reading pre, reading post. But if normality was not supported there, again, there is a non-parametric for this. You go to the same menu. Instead of 2 independent samples, we're doing 2 related samples. But reading pre and post up here. And what this is called is a Wilcoxon signed rank test. Okay, and we have similar findings. We do have a significant change in reading between pre and post. All right, so those are the big ones, the independent t-test and the pair t-test. This one's a little more rare, but I do see it run sometimes. It's called a one sample t-test. So this is used if you're trying to compare your data to a previous study's data. So you need to have literature to support what value you're comparing your data to. This is really easy to run. So you just go to Analyze, Compare Means and Proportions, and then one sample t-test right here. Then, say we put math scores up here and we looked in the literature and we saw that the average math score in previous studies was an 82. This is how you set it up. So you just put in your variable of interest, you put the value from the literature that you want to compare it to, and then you click OK. And we can see here, so our average for the sample was 85.31. And here's our test value. So the t-test is comparing the 85.3 to the literature estimate, which was 82. And here is the t-test you would report, the degree of freedom, and the p-value. We do have a significant change between our sample and the previous sample. All right, so in general, you want to pinpoint your research questions first. If you're planning to run t-tests, just make sure you have 2 groups that you want to compare. There's no overlap between the groups, or that you're looking for change over time. So maybe you have an intervention, you have pre-test, intervention, then a post-test, very common in nursing studies. I think a paired t-test is the most common test used in nursing studies. And then you can use SPSS, or you can use our company software, Intellectus, to analyze the data. So Intellectus will do everything that SPSS does, but it gives you an APA write-up automatically. So it's a big time save, and it's more cost efficient. So you can check that out if you're interested. And if you have any questions right now, you can type them into the chat box. If there's anything you'd like me to review again or go through in more detail, just let me know. We'll send everyone a copy of the webinar and the PowerPoint. All right, do we have any questions? Absolutely. Thanks for joining, Tammy. Sorry if I'm mispronouncing your name. Yes, Rosalind, we will send a link to Intellectus right now. Here, I can put it in the chat box here. The Intellectus website is in the chat box. Thank you for joining, Rose. Thanks, Eunice. Do we have any questions about t-tests or how to run things in SPSS? All right, no questions. Well, have a great day, everyone. We'll send a copy of the webinar and the PowerPoint, and come join us for future webinars. Have a great day.